Okay, this is the video for the review for the Algebra 1 Test 6, Inequalities and Domain and Range. On number 1, it says tell whether this point is a solution to this inequality. So what you're going to do is you have this point and it's 1, 10, which is x and y. And so you're just going to try to plug this into your inequality and see if it is a true statement or not. So if x is 1 and y is 10, you're going to come over here, and instead of writing y, you're going to put a 10. And then instead of writing x, you're going to put a 1. And then you just simplify. So we've got 5 plus 6, which is 11. And is 10 greater than 11? That's not a true statement, so no, 110 is not a solution to this inequality. Okay, so you're going to do the same thing on number 2. Number 2 says, tell whether this one is a solution. So this is x and this is y. So instead of writing x, you're going to put 10, and instead of writing y, you're going to put 7.5. So we say 7.5 is greater than or equal to negative 1/4 times, and then x is 10 minus 5. And then just take your calculator and type in your 1/4. So alpha y equals, and then enter, and that gets you your 1/4. So negative 1/4. Whoops. What happened here? Negative 1/4 times 10, and that's negative 5/2. So 7.5 is greater than or equal to negative 5/2 minus 5. And so then you're going to subtract 5, and that gets you negative 15/2. 7.5, let's just go ahead and make that a decimal so we can compare. And then 15/2, I can just divide it, and that'll get me a decimal for that as well, which is negative 7.5. So is positive 7.5 greater than or equal to negative 7.5? Yes. So this is a solution, so we would say yes. So on these problems on your test where it says tell whether this is a solution, you just take the ordered pair and you plug it into the inequality. Okay. Numbers 3, 4, and 5 are asking you to write the inequality that is represented by the graph. So what you're going to do is you're going to take a look at it, and you're going to decide whether or not you're talking about the line and also about the shading. So on number 3, it has a solid line, and it's shaded. So you just pick a point on the graph and you draw an arrow up so you know it's shaded above. So that means this is going to be y is on the big side of the inequality, and since it's a line, you're going to put that line underneath it. And then you just have to find m and b. So on this graph, b is right here, which is at 3, and m is, well, let's make it 2 pretty points. So this is 2, and this is 1, 2, 3, 4. So 2 over, oh wait, it's the other way around, 4/2. Remember, it's rise over run. 4/2. So that's 2. So this is y is greater than or equal to 2x plus 3. Okay. On number 4, it is shaded below. So this is going to be y is less than. It's going to be on the small side of the inequality sign. And it's a dotted line, so I don't draw a line. And then I just have to find m and b. So m and b. b is going to be negative 6. And then m, we need to find 2 pretty points. So this is 6 down, and this is 2 across. We don't say 6 down, we just say 6, right? So the slope is going to be 6/2, which is 3. So this is 3x minus 6. Don't forget when you're writing your equations to make sure you tell whether or not the slope is positive or negative. I know it's positive here because slope dude would walk up the line, he'd say puff puff positive. On number 5, same thing. So we're shaded above the line. So this is going to be y is greater than. It's a dotted line, so we don't put the line underneath it. And then find m and b. So b is 2. And M is, so 2 that way, 4 that way, so it's 2 over 4, which is 1/2. So this is 1/2 x plus 2. Okay? So when you're writing equations for those lines, you need to find M and B, you need to decide whether it's shaded above or below, and you need to make sure you look at the line to determine whether or not you draw a line. Remember that rule, it's see a line, draw a line. Alright, number 6. Okay, so on number 6, it's we're solving the inequality, so you remember you solve this exactly like normal equations, except for you have to follow the golden rule, which is if you multiply or divide by a negative number, you have to flip the inequality symbol. In this case, since the 3 is on the bottom, I want to get rid of this. So to get rid of it, I'm going to multiply both sides by 3. So that cancels the denominator. Can multiply that side by 3. So we get what's left on the side is 8d is less than or equal to negative 24 times 3, which is negative 72. I don't flip this symbol yet because I multiplied by a positive number. Now I'm going to divide by 8 on both sides. And once again, I don't flip the symbol because I'm dividing by a positive number. So d is less than or equal to negative 9. So you come over here to your line, you put negative 9 on the line, and then you're going to put a solid dot, and then a d on the big side or the small side. Well, in this case, it's on the small side, so I'm going to shade in the small direction. Number 7 is a little more complicated because we have variables on both sides, and also because we have parentheses. So what you're going to do is you're going to distribute first. So that's negative 3 times x, which is negative 3x, and negative 3 times negative 1, which is positive 3. Still keep that symbol in there. Copy the rest of it down. Now we have to find Texas. So negative 3 is bigger than negative 8, so I'm going to move everything into Texas. So that means 8x has to come into Texas. So this is 5x plus 3 is less than. This side cancels out, so the negative 2 is the only thing that remains. Now we have to get x all alone, so we're going to subtract 3 from both sides. So that's 5x is less than negative 5. Lastly, you divide by 5. So x is less than negative 1. My symbol remains the same because I did not multiply or divide by a negative number. Then put negative 1 on your number line. Because it doesn't have an or equals to at the bottom, this is going to be an open dot. And x is on the small side, so I'm going to shade in the small direction. And I'm done. Okay, number 8 and 9 are asking you to write inequalities for those situations. So it says that we've budgeted $400 for the purchase of new calculators. So that means that $400, is that a minimum or a maximum? $400 is going to be the maximum that they can spend. So that means the alligator is going to eat the $400. So I'm just going to put that on this side. Could I spend exactly $400 if that's what I budgeted? Yes. So I say or equals to. Then it says the calculators cost $70 each. That's a rate. So since that's a rate, it's going to get a variable. So we say 70 times x, or 70 times c. And that's how you get this one. Okay. Next up it says he took $40 to the mall. Is $40 a maximum or a minimum? $40 is the maximum amount he had. So he couldn't spend any more than $40. So the alligator's going to eat the $40. Could he spend all of his money? Could he spend exactly $40? Yes. So we say or equals to. Then it says he's purchased a baseball hat for $16.75. How much more money can he spend? So the baseball hat plus what else he's buying is going to be less than or equal to that $40. Okay. On numbers 10 and 11, it's just asking you to graph these inequalities. So you just have to look and see what number is actually on the number line. So in this case, there's a 2. So 2 is what's going to be on the number line. And then this is a closed dot because it says or equals to. And D is on the small side. So I'm going to graph in the small direction. Number 11, h is greater than negative 6. So put negative 6 on your number line. It gets an open circle because there's no equals to on there. And h is on the big side. So you're going to shade in the big direction. Okay, super easy. Alright, 12 and 13 require that you solve them first. So on number 12, to get x all alone, I have to subtract 14. So x is greater than or equal to 12. Put 12 on your number line. Gets a solid dot because it says or equals to. X is on the big side, so you shade in the big direction. Okay. Number 13, solve it. So we have to add 2 to both sides. So a is less than 3. Put 3 on the number line. Gets an open dot because it's not or equals to. A is on the small side, so you shade in the small direction. Number 14 says that Blaine graphed his number line inequality on the number line. Which inequality did he solve? So we really just have to decide whether or not it's an open or a closed dot, and it's shading in the big direction, right? So that means that x has to be on the big side. So x is on this side of these equations. So on this one, x is on the big side, so it could be A. On this one, x is also on the big side, so it could be B. C and D, x is on the small side, so it can't be either of those. So the last thing you need to do is you need to solve those. To solve those, you would distribute. So you're going to say this is 5x minus 15 is greater than 15. And then you're going to add 15 to both sides. Why am I adding above? Okay, add 15 to both sides. So that's 5x is greater than 30. And then you divide by 5. So x is greater than 6. Is that the correct answer? Yes. So it's A. Okay? Okay, on number 15, it says, what is a linear inequality? In order to graph an inequality, we have to solve it for y. So what we're going to do is we're going to look and see that all 4 of these problems all have 2x, or negative 2x over here. So the first step we're going to do is we're going to add 2x to both sides on every single one of these. So we would add 2x here, that says 12. So we're going to add 2x here, we're going to add 2x here, add 2x here, and add 2x here. That's what we're going to do first on every single one of these. Okay? The next step is we are going to have to divide by this coefficient. On the top 2, the coefficient is negative. So when I divide, that means that I'm going to flip the sign, right? So in this case, the y is going to end up being on the small side. In this case, the y will be on the big side. I don't have to flip here because I'd be dividing by positive 6. And I don't have to flip here because I'm also dividing by positive 6. So this one, the sign flips to be on the small side. This one, the sign flips to be on the big side. This one stays the same, and this one, the sign would stay the same. So since I'm looking at my graph and it's shaded below, then I can automatically cross off answer choice B and answer choice C because both of those answer choices say that y is now on the big side. So the last thing I need to do is decide which one of these actually follows this graph up here. So what you do is you write both of those equations down. So negative 6y is greater than negative 12 plus 2x. That was A. And let's go ahead and solve that. So it's negative 6 that we have to divide everything by. And that means that y is less than or equal to, that becomes a positive 2, and that's a negative 1/3 x. So m on this one is negative 1/3, and b is 2. Start at 2, go down 1 over 3. So A is the correct answer because it has the correct slope and y-intercept. Okay. Alright, number 16. Which inequality does not have the solution set graphed below? So on this one, we're going to end up having to solve for x on every single one of these problems. If you look at the coefficient of x, remember if it's negative when I divide, I'm going to have to flip the symbol. When I divide here, it's a positive, the positive 5, so when I divide, the symbol will stay the same, and negative 20 divided by positive 5 is negative 4. A solid line, solid dot, and x is on the big side, and it's shaded on the big side. So A is one that works. B, do the same thing, divide by 5 on both sides, we get x is smaller than or equal to negative 4. Solid dot, solid line, but x now is on the small side. It's asking for which one does not, so we can automatically stop at answer choice C. Okay. Alright, answer choice C says which ordered pair is in the solution set for this inequality. That's like the first two that I was going through when we started. Remember, this is x and this is y. Alright, so when I see answer choices for a problem like this, I like to just go ahead and plug in like the positive ones first and check them. So if this is x and this is y, when I come over here it's 12 plus, should zoom out some. So I'm going to do B first. So I would say 12 plus, and then y is 4, so 12 plus 4, less than or equal to negative 3 times 1. So that's 16 is less than or equal to negative 3. Is that true? No. So B is not my answer. Then I'm going to do the same thing for C and D and A. If you want to, you can just erase and try to solve it again, doing the same steps. So for C, I'm going to put negative 1 in for y, and 4 in for x. 12 plus negative 1 is 11, and negative 3 times 4 is negative 12. Is 11 less than or equal to negative 12? No. Alright, erase, do it again. This is why using erasable stuff is good. So now I'm going to plug in 3 for x and negative 16 for y. So it's 12 plus negative 16 is less than or equal to negative 3 times 3. This is negative 9 on this side. This side is negative 4. Is negative 4 less than or equal to negative 9? No. So it's not the solution. So that must mean that A has to be the solution, but let's just try it out, just to be sure that I didn't make a mistake. I have been known to make mistakes. So we put 3 in for y, and negative 16 in for x. 12 plus 3 is 15, and 3 times negative 16 is 48. Is 48 bigger than 15? Yes. So we did it right. Okay. Alright. These ones are asking you to write the inequalities, so you're going to have to go through and decide about maximums and minimums and stuff like that. Okay, so this one says the sum of a number and 2 is no more than 6. So this phrase is no more than means I'm going to have an inequality, and 6 is going to be my maximum. So that means I'm going to put 6 over here, and the alligator is going to eat the 6. Is it allowed to be 6? Well, if it says it's no more than 6, 6 is allowed, so we say or equals to. and then it says the sum of a number. Anytime you see that phrase, a number, that's x. So sum means to add. So it's x plus negative 2 is less than or equal to 6. You could have also put x minus 2 is less than or equal to 6. That would have also been correct. Number 19, a number decreased by 4. So a number means x, decreased by means subtract, is more than negative 1. So that means negative 1 is my minimum. So the alligator doesn't eat the negative 1. We say x minus 4. Negative 1 is not allowed because it says it has to be more than. Okay? Number 20. 5 times a number, that's x, increased by, that's plus 4, is no more than. So is no more than means that this side is going to be the maximum. So the alligator is going to eat this side. Is it allowed to be if I say no more than? Yes. So it's the number decreased by 9. So the number is x, decreased by means subtract. So this is x minus 9 on this side. And this side is 5x plus 4. Okay. 21. 21 says, the graph of the inequality of two variables is shown below. So the first thing I do when they give me answer choices is I decide whether or not it has the correct symbol. But the problem here is that all of them have the line underneath it. Remember the rule, see a line, draw a line? So I can't eliminate anything based on the line. But what I do know is that the line is drawn above, shaded above. So I need to make sure that I have that symbol correct. All of these have that symbol correct. So the last thing I need to do is I need to check it for it to say y equals. The first step on A is going to be to subtract 3x. The first step on B is going to be to add 3x. The first step on C is going to be to subtract 3x. And the first step on D is going to be to add 3x. Because I want to move that 3x from this side to the other side. Okay. The next thing I'm going to do on A is divide by 2. And remember, you have to share the love. So this is y is greater than or equal to, this is 1 minus 3 over 2x. Up here, what's m and what's b? Well, b is negative 1, so I can automatically cross off a because b is 1 on a. M is that can't be right. Let me try this again. It's hard to see where the pretty points are when they're so small. And actually that was 6 and 4. That was right. Because I'm 1 below. So this is going to be 6 over 4, which is 3 over 2. So we want a positive slope and a negative y-intercept. So here I'm going to divide everything by 2. So I get y is greater than or equal to 1 plus 3 halves x. I have a positive slope and a positive y-intercept. That's not what I want. I want it to be negative 1, so it's not b. Number 3, divide everything by 2. So we get y is greater than or equal to negative 1 minus 3 halves x. Well, now I have a negative slope, so that's definitely not it. D has to be my answer, but I want to check and make sure I didn't make a calculation error. So I'm going to divide by 2 on all parts. Y is greater than or equal to, this is negative 1, and this is positive 3 halves. So that ended up being correct. Negative 1 and positive 3 halves x. Alright, number 22, thank gosh, is so much easier. So if you look at number 22, it has a dotted line. All of those have dotted lines. It is shaded above. So that means y needs to be on the big side. So that means I can eliminate a because a has y on the small side. I can also eliminate c because y is on the small side on c. So now I just have to determine which one of these has the correct slope, because they both have the same y-intercept. So you draw your slope triangle. This is 1 and 2. So the slope is 1/2. So D is the correct answer. Okay. Number 23 says which graph matches this. So that means you're going to have to divide by 3. Or sorry, -3. When I multiply or divide by a negative, what happens? The inequality flips. So we have x is less than -2. Does that match? Yes. On number 23, it says which one does not have the solution set graph below. So if A is correct, it can't be my answer. Divide by 3 here. This says x is less than -2. Is that correct? Yes. Divide by -3 here. This is x, and because it's a negative, I have to flip the symbol. So it's greater than -2. Is that true? No. So C is the correct answer. 24, 25, and 26 are asking you to graph the inequality. This one already says y equals. So M is 3, which is really 3/1, and B is 0. Start at 0, move up 3/1, and down 3, back 1. Okay. 25 says you have to solve for y first. So I'm going to use some white space over here. 2y minus 4x is less than 8. So to get it to say y equals, first I have to add 4x to both sides. 2y is less than 8 plus 4x. Okay, and then the last step is to divide by that 2. Remember to share the love. So this is y is less than 4 plus 2x. Okay, so M on this one is going to be 2/1, and B is 4. So we begin at 4, and it's 2/1. So up 2 to the right 1, and then down and back. The symbol on this one is not a solid line, so we give it a dashed line. And on this one, y is on the small side, so I'm going to shade down. Holy cow, on number 24, I totally forgot to shade. I just graphed the line. Y is on the small side, so that means I'm going to shade below it as well. Okay. 26, we still have to solve that one for y also. So we're going to subtract 3x from both sides, and that gets us y is less than or equal to 4 minus 3x. Now it says y equals, so we can graph it. M is -3, and B is 4. So that's 3/1. So we begin at 4, and we're going to go down 3/1. Down 3/1. It's got a solid line, so I'm going to draw a solid line. Remember, see a line, draw a line. And then y is on the small side, so I'm going to draw down, and that's the side I draw on. Okay. Alright, number 27. Number 27 says to graph this inequality. So first we have to get y all alone. So I'm going to do it down here. 3x minus y is less than 4. So we're going to subtract 3x. So that gets me -y is less than 4 minus 3x. What's hiding behind or in front of the y here? A 1. So I have to divide by -1 on all three parts. So this is y is greater than -4 plus 3x. Turns into a greater than because I divided by a negative. So on this problem, M and B M is going to be 3. B is going to be negative 4. So begin at negative 4 and move 3 over 1. Up 3 over 1. And on this problem, it's not a solid line, so it needs to be a dotted line. Y is on the big side. I'm going to shade on the big side. That means I pick a point, draw an arrow up, and that tells me which side is the big side. You're done. Okay, 28. Same problem, different symbol here and here. You're going to do the same steps. So we're going to end up subtracting 3x from both sides. So this gets me, I'm going to write it down here, negative y is greater than negative 4 minus 3x. There's a 1 hiding to divide by negative 1. That means I have to flip the inequality symbol. So this is y is less than positive 4, and this is positive 3x. M on this one is 3. B on this one is 4. We're going to start at 4. We're going to go up 3 over 1 and down 3, back 1. It's going to get a dotted line. And y is on the small side, so we're going to shade down. So you pick a point, draw an arrow down, and shade on that side. Okay, on number 29, we just need to solve for y, which means we need to add 3x to both sides. So down here, it's y is greater than or equal to negative 4 plus 3x. So m is 3 and b is negative 4. So we put a dot at negative 4, and that's 3 over 1. It's a solid line. And y is on the big side. So we're going to shade above, which means I'm going to draw an arrow from one of the points above the line. Ta-da! Done. Okay, so the last section is over domain and range. So let's look at example 30. On example 30, we're going to draw the sides of it for domain. And if you notice, on the left side there's no arrows, but on the right side there are arrows. So this is at negative 1, 2, 3, 4. So we say x, and the arrows are on the big side. So we say x is bigger than or equal to negative 4. We say or equals to because it's got a solid dot on this blue line right here. The range is the top and the bottom. If I draw an arrow on top and an arrow on bottom, both sides have arrows, so this is going to be all real numbers. On this problem, it is not a function because if you notice my blue line that I drew right here went through 2 parts of my graph. So we say this one's not a function. 31, we're going to draw our sides. So in this case, both sides have dots, so that means x goes in between. On this side, it's at negative 5, and this side is at 5, so we're going to put those on either side. And now we just have to look at what kind of dots we have. We have an open dot here, so we leave the symbol alone. We have a closed dot here, so we're going to put or equals to on the bottom. Now we're going to do range. Range is the top and bottom. So this one, the top and the bottom, neither of them have arrows. This bottom is at negative 3, and this top is at 5. So we say negative 3 and 5. Always put your smaller number on this side. Okay, and then y is going to go in the middle because we're talking about range. On the bottom, negative 3 has an open dot, so we just put this symbol and leave it alone. On the top, there is no dot, so we say it is a closed dot, and so we put that symbol. If I were to draw lines all the way through this graph, they would all touch the graph in only one place, so this is a function. Okay, On number 32, this one is not a continuous graph, so we have to put a list. So what I always do is make a table of the ordered pairs. And I'll just start over here. We're at 1, 2, 3, 4, so -4, 2. Now, for some reason, this one's numbered outside of the graph. I don't know why, but actually, if you look at it, this y right here tells us this is the y-axis, and this x right here is telling us that this is the x-axis. So that's how I'm getting that ordered pair, even though the numbers are out here. Okay, so this is at 0, 1. And this one is at -1, 1, 2, 3, -4. And this one is at 2, 5. And this last one is at 5, 0. So when you list your domain, you can do little squiggly lines and just go in order from least to greatest. So that's all the x values. So -4, -1, 0, 2, and 5. And then on the range portion, that's going to be your y values. Those are all these listed right over here. So you do a little squiggly line and you say the lowest number is -4, then 0, 1, 2, and 5. Is this one a function? Yes, because if I draw my vertical lines, it only goes through a point on the graph one time every single time. So yes, it is a function. Ooh, I super duper like number 33. It is a continuous graph, so I can draw my sides of my graph, my borders, or my boundaries, I mean. And so that means that the domain is going to be all real numbers because both sides are touching arrows. And then if I draw my boundaries on top and bottom of the graph, same thing. Both of the orange lines touch an arrow. So that one is also all real numbers. Is this one a function? Yes, because if I drew vertical lines all the way through it, it's only going to touch it in one place. So yes. Alright, almost done, guys. Hang in there. 2 more questions. If I draw my boundaries on number 34, the blue lines both touch an arrow, so that's going to be all real numbers. If I draw my top and bottom, the boundaries, only one side touches an arrow. So this is a solid dot up here, and it's getting smaller. So y is less than, it's going to be on the small side, or equals to. And honestly, oh here, you can see it right here. Here's the x-axis right here. So 2. Too high. Here's the y-axis. Okay? Alright. And yes, this one is a function because if I drew vertical lines all the way through it, it only touches the graph one time. Last one, number 35, domain and range. Draw my boundaries. And this one also, it's really hard to see that x and y axis, so let's go ahead and make sure that's a little bit darker. You can kind of see the arrows on the side of the graph right here. Okay, so -1, 2, 3, 4. So this one's at -4, and this one's at 1, 2, 3, 4, 5. So the domain is in between 2 points. It's between -4 and 5. And then we're going to put x in between them. And then on the left side, it has a solid dot, so it gets a line under it. On the right side, it has an open dot, so it doesn't get a line under it. It just stays like it is. Now we'll draw our top and bottom boundaries. On the top, we're at 0. Whoops. 0 is going to be bigger than the other number. Always make sure your smaller number is always on the left side. So here we've got 1, 2, 3, 4, 5, 6, I think that is. It's hard for me to see right now. Okay, so y is going to be in between -6 and 0, right? And then on the -6 side, I have a closed dot and I have an open dot, okay? So anytime you have both of them, it's not included here, but it is included there. So like if I were going to list out all of my points for this graph, then it would be included on this point right here. So I would have to say that is part of the range, so we say or equals to. So if you see an open dot and a closed dot on the same boundary, you always assume that it's closed. And then on the top is an open dot, so we just leave it alone. And then is it a function? Yes, because if I drew a vertical line all the way through it, I would only touch the graph in one place, everywhere. So yes, it is a function. Okay, that's your review for your test. Please study. Make sure you understand each question. If you have any questions, as always, please come and ask me or your teacher. Thanks so much and have a good day.